Sorry, so just to introduce Jim. Jim Rowe is a member of the Meteor group, and Jim is involved in expanding the FRIPON network into the UK and hopefully Ireland as well soon as part of SCAMP, and maybe give us a talk about this. Thank you.
Very good. Well, thank you for having me over here. I run the East Barnet Nemetode station, which is also part of the UK Meteor Observation Network, and increasingly as part of FRIPON. But I'll give you a run through what FRIPON is, what SCAMP is, and what we're up to there. The photo here is the Manchester-based FRIPON camera on Manchester University, and FRIPON is primarily a French meteor network, the aim of which is to find meteorites. And it's all going very well. The one thing that they're anxious about, though, is they haven't yet recovered a meteorite. But given time, I'm sure we will. So, SCAMP, FRIPON is the Fireball Recovery and Interplanetary Observation Network. But in French, FRIPON means playful or mischievous child. We came up with an acronym after trying half a dozen, which was the same meaning: System for Capture of Asteroid and Meteorite Paths. Don't think about it too much. The acronym works, and that was the main thing. So it's the extension of the FRIPON network into the UK and Ireland. It started out as just an unofficial attempt to really just deploy their kit and see what happened by buying it and whacking it on buildings and connecting it to a computer. But as of June, FRIPON involved all of the informal non-French networks with a view to integrating them and extending their reach, and so we're part of that. The collaboration in the UK is with the Natural History Museum, University of Manchester, UK Meteor Observation Network primarily, and UK MON because of their very web and social media ability. This is the existing FRIPON and SCAMP network. The main core FRIPON network there is in blue, light blue, red and black. I think the red is the ones that are offline, black is with radio. I'm not exactly sure the color coding there. Green is the Prisma network, which is Italian, based in Milan. The blue off to the right is the Moroi network in Romania, and then there are a few other scattered ones. And the solitary SCAMP camera that's actually online and part of the FRIPON network is based in Honiton, and that was provided by FRIPON and is run by Alan Shuttleworth there. The other two, Manchester and East Barnet, you can see up in the map in the top left, are running, and they're capturing events, but they're not yet integrated into the FRIPON network. And that will change this week or next week, where we're actually using the right kit and integrating them with the FRIPON virtual private network. So at the moment, one camera connected, two others that are going to be, that are running but are going to change computers and change and become part of the virtual private network, which will be three, sorry, I can't add. Arma, I have their camera in my bag, and so that will be installed hopefully over the next few weeks. And then we've got two more to deploy, and then we need to find some more money. So this is what we're looking for, is on the top right, chunk of rock. And to find the chunk of rock correlated with the orbit. So the main aim of FRIPON is to recover meteorites. It's like a little mini sample return mission. So you've got the two asteroid missions going on at the moment. They're incredibly expensive. They're going to bring back pristine samples of asteroids. This is a cheaper way of getting a bit of asteroid return, actually correlated with the orbit, so you know where it came from. Not pristine because it's been through the atmosphere and it's landed on the ground, but not too bad probably. The FRIPON cameras are much less sensitive than Nemetode type cameras. They only pick up bright events, so we only record sort of one event per camera every couple of days. It doesn't pick up aeroplanes, fortunately, or flashes or less sensitive events. The software was written by the FRIPON team. It's called Meteor. It's open source software available on GitHub, and anyone can download it, adapt it, and do things with it. So really, I suppose we're after, if you think of the chunk of rock in the top right as the cause of the problem, then Nematode's looking at the symptom, being the meteor, whereas we're trying to actually find the problem itself, the meteorite. That is the Anima meteorite recovered by the Finnish Viable Recovery Network. And one of the academics at Helsinki University, Maria Gritseva, has done some really good work on atmospheric modelling. So her model has led to the recovery of 2 meteorites now, which of course causes anxiety for FRIPON because they weren't part of that network. Okay, here are some example fireballs. You will have seen them, but any excuse to play them. This was Lapland earlier in the year, and you can see how this would saturate a nematode camera if it is actually playing. Okay, so casting a shadow and then brilliant light, and on the nematode camera that's just going to be a white screen, and UFO capture is going to be very confused. Or UFO analyzer. And then the Chelyabinsk one is maybe not going to play. Okay, well you've seen that one anyway, a million times, but I don't know what that thing is, but it's on the video. Eventually the FRIPON network will run during the daytime as well, but they haven't got that figured out yet. The cameras are okay, now I have to find a way of stopping this. I don't know what they're saying in Russian. So I suppose any questions so far on that? Or I just keep powering on, questions at the end. Okay, so this was FRIPON conference in June 2018 in the amazing surrounds of the Council Chamber of the Paris Observatory, which is an institution as old as Dunsink or Amar. And really this was the bringing on board of all of the foreign efforts. And so you can see as the main core FRIPON team there chairing it. And I think Laplace might be one of the portraits up there of the good old boys of French science, all celebrated in there. Now the equipment, I have brought with me one I made earlier. Well, I didn't make it, but it's from made by Chaliac Cameras in France. I hope you can see it, but it's basically a fairly small. It's got a Basler digital camera in there, an 185-degree lens, so quite short focal length there, and then a 50mm Perspex dome on top. Yes, you'll see it better in the light, I guess. It's designed really to be off-cooling, so typically the interior is about 8 degrees warmer than the outside, and so it's enough to keep dew off. It hasn't got its own heater in there, and it runs on a power over internet cable, so it just has one cable. It can be cabled up to 100 meters away. So it's a very nice piece of kit designed for FRIPON, and so really the easiest thing to do. We tried experimenting with building enclosures, and I know we had a lot of correspondence about that. I thought the easiest thing to do is just go with their enclosure, it works well, and use their kit, and just try and deploy it. So this one will end up at Alma Observatory sometime in the next few weeks, hopefully, once we get it configured.
More than I expected.
Yes, yeah, it is really compact and quite unobtrusive. And so if you've got a historic building and you want to whack something on top, then people won't notice that, hopefully. That's the objective.
Do they sell those?
Yes, you can buy them from Chaliac Instruments in Grenoble. You have to talk them into selling you one. They've actually said no sometimes, and which is unique. They cost about €1,000 a go. The total system, I suppose, costs about £1,600, so about €1,800 to build. So they're a lot more expensive than the Nemetode cameras. A lot of that actually is Shellac's margin. If you price the components of it, that's about half of it, and the rest of it is their costs and profit margin. But at the moment, while getting the network, they've got the camera under development. They're going to try for simpler and cheaper cameras. And so one thought is use Raspberry Pi camera and have a Raspberry Pi in the enclosure and do all the processing in the enclosure. And so that'll be the next generation, I think.
They wouldn't sell you the enclosure because
That's right.
Yeah, and I tried as well. So, and the answer was no. So, almost a polite no.
Is the camera taking a video image or as an integrated image over 10 or 20 seconds?
It's doing very much the same thing as the WATEC and UFO capture. It's a frame stack. It's 30 frames per second, and it's just shooting the frames through to a computer, and then the computer's keeping the frame stack and monitoring it, and doing the same calculations. So that's what's inside there. That's the setup, and that's a prototype camera, but it's basically a power over internet switch. That's in an Intel NUC computer, next unit of computing, and so we've set up 5 of those now for the rest of the network. We'll start deploying those. So Thomas, you'll see something very like this, except with that camera attached, turning up in the post sometime in the next week or so. Here are the 3 current deployments. The first one in the UK was in Honiton. I thought I had the first one in the UK until Alan Shuttleworth popped up and saying, oh, except for mine. So we've worked quite closely together since then. The second one in Manchester you've already seen on the University of Manchester. And the third one is on my home. That's my chimney, which fortunately I don't use. Now, that's the view from it, and this is a capture on New Year's Eve, and you'll see a tiny little white dot crawling along the bottom of the frame there, if it hasn't stopped. Okay, you can see it here. Now, the reason that it's so faint is that's actually 300 k's away. That's up near the Wash, whereas my camera's in London. And that was a very bright fireball event on New Year's Eve that was reported by, I can't remember how many people, I think it was several hundred, and made media coverage. And so I was quite pleased that we actually got that. It's a small memento of the first sort of serious capture. The Manchester camera has since caught some good events. Next steps are, now that's a photo taken by Tullis of the Met mast at Armagh. That's where this camera is going to go a couple of weeks from now, somewhere at the top there. But really, the next steps are to deploy the Armagh camera, get the East Barnet and Manchester cameras onto the FRIPON network, and that will happen next week. Continue to work with the UK Natural History Museum on recovery, and Ashley King of the Natural History Museum has put together a bit of a skeleton crew to go find meteorites if they land. But when we had one that looked as though it had landed in Hampshire in November, no one could really agree what to do next. And so we're having a meeting sometime later this year or early next year to decide what to do if we actually identify that a meteorite has probably landed in a particular part of the UK. Then who does what, and when do we do it? And so it involves working out a skeleton media pack, working out what sort of media you aim for, whether it's local or national, what message you want to put out to local people, and then who turns up and what they do on the ground in order to actually recover the rock. The aim is that it ends up in the Natural History Museum rather than in the hands of American collectors. Now, I mean, it's better that it's collected by someone, but even better that it be the Natural History Museum in the first instance. So that's it. So I suppose questions, please.
Thank you.
I think
That was one of my first question actually, what protocol you have. So obviously you're trying to decide that, and do you go with the mass media coverage or do you try and find it privately yourself first?
Yeah, I think probably go with local media and then have a group of people who are prepared to sort of, unless they really can't do it, drop everything and go down there. We've drawn on the experience of the IMO, who said that as soon as they published a Meteor path, within 5 hours they had collectors there on the ground trying to find it. Using national media will give the same result probably. The VigiSeal team, which is the sort of public outreach team of FRIPON, have found that turning up fairly quickly, trying not to be seen as the people from head office, but actually trying to do outreach events, knocking on doors, and actually taking around a sample of what you're looking for. So saying, this is a meteorite, have you seen anything a bit like this? They're useful for science, and it'd be great if you did. The local media tends to be print-based, so might come out a week after the event. And so having a lot of flyers ready and stuffing them through doors is a possibility. If it's landed in a rural area, then obviously working with land registry data and trying to find out who owns the land and go knock on their door. The downside with using sort of scattergun media or social media is convincing 12-year-old boys that they should go climb on a factory roof to see if it's landed on there. And so legal people at Natural History Museum were not enchanted with the idea that they could be held responsible for broken arms and worse. So there's more to be done, but the aim is to, it might involve a couple of really good events where we're going, kicking ourselves under the table for not being ready, but we'll get there, hopefully.
And in terms of your, the analysis, so for the analysis to occur, you need at least 2 cameras or more? What's the minimum number considered?
Yeah, 2 is the minimum number, and obviously the more you get, then the more accurate it is. There are still a lot of false captures, and so the FRIPON network is working off getting at least 3 captures before they get interested in an event, and preferably more. Really big events get caught by about 6 cameras, but the network, as you can see, is very dense in France. They've aimed for a camera. It's really optimal for the spacing of them. And at the moment, I think they use a trigger of 3 on them.
And in terms of the analysis, and then I'm thinking as well the whole dark flight analysis, how is that handled?
From my point of view, it's a total black box. From their point of view, they have meteorological models. They treat the sort of visible part of the flight as a straight line, which tells you the initial trajectory, and then using an atmospheric model and wind data to try and figure out where it lands. There's a lot of information about mass that you can pick up from the deceleration that's shown in the lit path, and then from the mass you can guess then how it will behave in its fall. The best dark flight model seems to be the Maria Gritseva and her team, and it's been very successful in pinpointing where the objects should be found. So.
If you have a camera like one of these and it's connected to the network, will the actual camera, you photograph one of these events in 2 or 3 days, will you know, A, if it's been captured by other cameras in the network, B, if it's of interest in terms of the meteorite dropper, or will you be sort of disconnected from that?
Yeah, you're really quite disconnected from it. You end up being just a passive supplier of internet capacity and electricity, to someone else's camera.
So you are disconnected.
You are pretty disconnected, but the cameras provide a feed onto the FRIPON website, so you can actually look from cameras on there. And once we get 4 to 6 set up in the UK, then we're going to set up a data mirror so that the data gets mirrored back to the UK, and then people can access it off that mirror. And that's what the Dutch have done. The ESA had set up a network in the Netherlands, which has got quite a good group of cameras there, and a data mirror which picks up the data from the FRIPON server in Marseille and mirrors it back, and then we can do what we like with that data.
The reason I asked the question is that I actually got a grant of £1,600 to buy such a camera.
Oh.
But because the planetarium is obviously a science centre and an outreach centre,
Yes.
the condition of having the grant was that we would be able to use it for outreach.
Yes.
And I feared, having looked at the way it was at the moment, that you would be rather disconnected, and so you wouldn't be able to use it for outreach, which is the actual purpose I got the money.
No, absolutely. No, absolutely. And this is the same problem.
What you're saying to me is good, but I wonder how long I've got to wait.
I'm not sure. We've got a lot of help from the Dutch network. Once we get the critical mass of cameras set up, then I'll work with them to get the data mirror set up. But this is the same problem as Amar pointed out, which is that it needs to be useful for public engagement. Otherwise, why bother? Why supply the power in the internet? You're just another dot on a map.
Yeah.
So that is something that we need to crack. So at the moment, you can pick up an image from it, but you can't at the moment even pick up the AVI clip that it produces, because that's actually on the computer, the little nut computer, but at the moment isn't saved for more than 45 days in France. So the Dutch have worked out how to pick that up off the server using a mirror so that you can then use it in your public engagement.
It's a standard power over Ethernet camera, which goes through a PoE hub. So why can't you just connect to it as a secondary user and just take the video that way? So I mean, there presumably isn't a kind of contractual thing that says that you can't do this.
No, I don't think there is. But that network ability is above my... Then let's do it.
Yeah, I mean, PoE cameras, everything is power over Ethernet now. I assume that one is similar. They will have the ability for multiple clients to connect to the camera simultaneously. So,
What's great about Nemetode is that when there's a bright event or whatever, everybody knows about it. And the mailing list goes out, you know who's captured it, you see the clips, you feel part of it all. That's what's great about the Nemetode network. You're not putting the data into a black hole which you never see. And even if you haven't contributed to the particular thing, you can see, because of what Alex and William and the others do, exactly what's going on. That's great to feel part of it.
That's what I want.
I would like to feel part of this, but I don't see at the moment that's the case.
No, that's where we'll get to. I mean, I'm just an amateur. I started off with the Wattek cameras on my roof, and it's just through sheer blood we've ended up having something that's been integrated into the FRIPON network.
Would you be willing to do a couple of quick experiments? Because I'd like to tell you very quickly what you could do with a laptop plugged into that PoE.
Yeah, absolutely.
You download a client called OMVIF, which is a client which will basically scan the PoE cameras and display the video of the camera. And assuming that that works at the same time this thing is doing its normal stuff for a little Intel, then all you need is a simple Windows client, and it can record the video from the camera for you, or display it simultaneously, or all kinds of things.
Okay, well let's do that.
Well, that's the thing. I mean, if there is some kind of contractual thing that says you're not supposed to do.
Well, all that computer sees is a fisheye into the camera. You need to store what it is. It's a firewall camera part of the Meteor roof then,
But, I mean, we will get there using the FRIPON route with the data mirror. The Dutch network had the same problem. they weren't part of FRIPON, and they've now got satisfactory access to the data and to the clips and so forth. And they've said that they'll help us set that up. And so at the moment there's nothing to set up because we only have the one camera working, but once we've got 4, then we'll use their help to get the data mirror set up. And then we've got real-time access to it. So.
But having it fully, you would say, autonomous might be an attraction to some people. Because they might just, okay, put it up on the roof, we don't need to worry about staff members or students or personnel or amateurs going up and trying to, processing files. It just does it, just works its own magic.
Yeah.
And we get the data out if there's a bright firebolt. So
yes.
So.
I'll be in trouble with ARMA if we don't get the public engagement right. And also I'll get quite bored myself because I like seeing the images of the clips, and at the moment I've got it sort of set up with a computer that I've set up myself using their software but not connected to their network, so I've got access to all of the data. And so to get back to that position, I'm going to go with their official and then mirror the data back. And so I'm highly motivated to get back to that position. So yeah, I think we'll get there with that. So yeah, go for it.
So it's a wide-angle lens. Your positional accuracy that you're able to measure from that video image is not going to be as good as an image you would get with a longer focal length lens.
Yes.
You can offset that with a lot of cameras scaled across the country. So in order to get good enough positional data, such that you can really narrow down that bleed field, how many cameras are you going to need in the UK? You talk about the flances maybe separated by more than 100 kilometres.
Yeah.
You're going to need the same sort of setup in the UK?
Yeah, I think ideally getting about 30 scattered across the place would do it. The Desert Firewall network is also setting up, and so we're quite friendly with them, but at the moment neither have got enough deployed to even to quit. The aim will be cooperate with them and share data with them. So really it's just a matter of building it to the point where it's actually useful, while in the short term hoping we'll fluke it with ones that are caught by all 3 or by 3 of the 6 that are in the UK, or that we get captures that are caught by some UK cameras, some French cameras. But the calibration and image processing is quite interesting. It's quite sophisticated. So they use a 16 variable equation to actually convert the image into the star map, and which takes account of some quite odd lens distortion by the Perspex dome as well. And so 8 variables of that are just standard sort of positional stuff to do with, and then the other 8 really describe distortion and lens quality issues and dome issues. So they really are trying to get the most data out of the captures. Yeah.
Understood. Is it, what sort of resolution is the camera? Is it 640 by 480 or HD camera? Or?
I've forgotten.
2 megapixels.
2 megapixels?
Yeah. Okay,
so
thanks.
Arc pixels is going to be okay.
Possible. Thanks. Thanks. Thank you.